figures, right? And do we see why it's obvious that we put the angles on the inside? I mean or not the angles, but the letters, the labels, because otherwise we wouldn't be able to see them. So on number 2 it says to take angle B and place it on top of each angle. One of them it'll match up. Well, does it match up with A? Does angle B match up with A?
No.
Pretty close to E.
No.
But it's still a little bit short, you see?
No.
Okay? So this is what it meant one by one.
So I got A.
If you cut it out and drew it right, it should be D. Okay? So that's what you do. So what angle goes with angle B?
B.
What angle goes with angle B?
D. Angle D. Angle AD.
Okay, why are we saying different things? Angle B goes with angle D. Only, you can't say, Maurice, you can't say AD. Maurice. It's only that one angle D. Okay, now you could say angle ADE, but it's either angle D or angle AD. It definitely goes with D. I don't think that you were exact right there. You see how you didn't cut? And that wasn't exactly straight. You see how the angle comes out? So I think if you used your ruler, you would have gotten more of the angle there. Okay, and then when we match up angle C, which angle went to this one? Which one? Did y'all match it up? See that went together? Okay. And that's what we should have gotten. Now it says in the diagram, DE and BC are parallel, intersected by AB and AC. So do we see that these two lines are parallel? And they're intersected by AB and AC. There's something special about parallel lines in an intersection where it comes through. What do you know about the measures formed when a line intersects two parallel lines? Okay, so this is what they're talking about. In math, have you seen something like this before?
Not equal.
Yes, but this is not a symbol. These are parallel lines, and you see where did you say you seen it?
Last year.
I've seen it. Yes, you can definitely do another line through it.
I see it on the graph.
Okay. Corresponding angles, alternate interior angles. I think some of you are not listening and paying attention because we're going to do a blast from the past, meaning we're going to go over something you learned last year and you might not remember it.
Also the supplementary and complementary.
Yes. Supplementary angles are angles that measure 90 degrees. And in this case, we're not going to have that. But we do have supplementary that equal 180 degrees.
I thought that was complementary.
Complementary is 90 degrees. Supplementary is 180. So remember, C comes before S. So C is 90, S is 180.
Okay.
All right, Maurice, what were you going to say? just asking.
Yeah, did we go over similarity, similar triangles and stuff earlier?
No, I could have done a bell ringer or something where I talked about it, but we haven't actually went over it yet. This is called a transversal. A line that goes through two parallel lines is a transversal. On here, do we have it happening as well? Do we have a transversal? Tyler, what color is a transversal line on this one? Hey, you're not paying attention. That's what I thought on you. So look up here. What color is a transversal on this picture? Did you hear me what I said a transversal was? Okay, so we're not paying attention, are we? I'm gonna come back to you, so keep listening. Someone raise their hand and tell me what a transversal is. Elisha?
A line that goes from two parallel.
A line that goes through two parallel lines. So on here, where are your parallel lines? Child. You can look up here. Where are the parallel lines?
And B, E, and BC.
Yeah, the two red ones. So what would be your transversal?
A, B, and AC.
That green, because it splits it, Maurice.
A, what's the second? On the side where the C is A.
E.
Yeah.
Yeah. You would actually go ahead and say AC. Good thinking. He said AE, but you would actually go ahead and say AC because this is kind of like a middle point, and you do the outside. But good thinking. Okay, so we have a transversal. Now we need to figure out some special things about these angles. Okay? What is that form?
To an obtuse angle and acute angle?
Yes. A straight angle. So what type of angles are these? If they make up a straight angle, supplementary angles, because how many degrees are in a straight angle? 180. Right? So these are supplementary. Now, what is special about the angles underneath them?
Those are the same.
They're the same. On Raven, 3 and 4, what type of angles are those? Mm-hmm. We just, no, because it's a slight diagonal, that transversal. But we just said that 1 and 2 were a certain type of angle, and 3 and 4 are the same. Were you listening? We have a video in here and we're not listening? Second person, right? And is there only 2 people in here probably not listening? When you don't listen, you miss those little things, right? Alright, so, Caitlin, can you tell me what 1 and 2 are? What type of angles? Straight. They're straight and we call them, what's her name? Let's not answer for it. Katrina? Do you remember supplementary? Because how many degrees are in a straight angle? 180. So now look at 3 and 4. Do they look similar to 1 and 2? Does it make a straight angle? So how many degrees is 3 and 4 together? 180. So we have on the top creates 180 and on the bottom creates 180. Because, very good, because all around it would make 360, right? Did I draw a circle if you connected all of them?
Yep.
Okay, so now there's something special about 1, 2, 3, and 4. Look at all of them. Heather?
They're adjacent.
They are adjacent. Some of them. Which ones would be adjacent?
4 and 2, 2 and 1 and 3 and 3 and 4.
And we'll talk about adjacent. Adjacent means that they are side by side and they share a side. So if you did 1 and 2, they share this side right here. Okay? What else do we know about them? Something about 1, 2, 3, and 4. Something that we can start putting together. Elisha? No, these don't. I didn't mean for them to. You see I have a slight slant? Could they all have right angles?
Yes.
Yes, but this one is not supposed to. Brendan?
One's obtuse and one's acute.
One is obtuse and two is acute. Kevin?
They're opposites, where one is obtuse, 3 is acute, and where 2 is acute, 4 is obtuse.
Yeah, so if one is acute, 4 is acute, right? And if two is, and if 2 is obtuse, 3 is.
Acute.
Number one.
Oh, did I say the wrong way? I'm sorry. So 1 and 4 are obtuse, yes, because they're water, sorry. And 2 and 4 are acute, or 3, sorry, 2 and 3. Okay, so now, what do we know from that? They're opposites of each other because of this line, right?
Yeah.
It splits it both the same way. It splits that line the same way. So Zach, I put some color codes on there for a reason. What could we say is true about the angles?
Two obtuse, two acute.
And take that a little bit further. Why do you think I did blue, blue, green, green?
Which ones are which?
But if I use the same color, what would that imply?
That they're all the same.
That they're all the same, or the colors? If they were all the same, couldn't I just color them all green? Or all blue? But they're not all the same because we said some were obtuse and some were acute. So what could we imply? Okay, let's make up some measures. What do we want this one to be? I'm gonna come back to Zach. What do we want this one to be at? An obtuse angle.
An octopus.
35.
Okay, if that's 120, what does this have to be?
45.
16.
Guys, how many degrees are in a straight angle?
180.
So if this is 120, what does this one have to be?
60.
Alright, what measure is this gonna be? How do we know it's 60? And this split them the same way, right? So Zach, what could you imply about those two pairs of angles? Yes. Which ones would be congruent? You can just say colors. Good. That's what I wanted you to go with. They are congruent. They're equal, guys. There is a theorem that you can prove, but it says that vertical angles are equal. Remember that? Vertical angles are equal. Aren't these vertical? Tally, looking up here. Are these vertical? Vertical doesn't mean they have to be directly on top of each other. It just means that they are,
Straight.
well, they're here and here, here and here. You can rotate them around, but they're still connected like this. Okay? What would happen if I took this and rotated it around? It would look the same, wouldn't it? That's another way you can visually see that those are equal. Okay, so now let's look at the bottom line. Did it create angles as well? It created the same angles, didn't it?
This turn.
Actually, opposited them.
No.
No.
Look, that's the same.
Oh.
Yeah. So, does someone want to come color code those? Tyler. So this is a little geometry lesson. Okay, so hold on just a second. Someone want to explain something to him? Zach?
They got them mixed up.
Why?
Because the blue should be where the green on, because that's where the two acute are. And the blue should be where the
heard someone say opposite, but look at it truly. Look at this measurement visually. Is this the same as this one? Do you see it? Do you see how it angles out? Does that angle out? Does this angle in? Does that angle in? Look. So they're the same, right? Okay, so you want to redo the colors, please? Okay, good. Now, the reason why I'm showing you this is because it is similar to our triangle. Look at, remember what we called the transversal? Is the green lines? That line that splits them? Y'all see where the red lines are the parallel lines? This is similar to our triangle. Okay, Courtney, do you see angle B and D on the big triangle? We said those are equal. Looking at the angle measurements that we did over to the side, what color would B and D be? Yes. You want to go and draw it for me? And then show us why. You can reference them. Mm-hmm. Okay, so why did you color that blue? Okay, do y'all see that, guys?
Yes.
How they're in the same spot as the blue? Okay, say, look. Is it, hold on, but are they opposite or are they on the same side?
Opposite.
No, look at them. Look back down, look up there. Yeah, doesn't that look like the same spot? Point to it again. That one and that one, you see how they're on top? And that one. Yeah. On our, the triangle that we drew, we only need one side, right? That one looking. We don't need this over here, because we don't have any angles over here, right? But what we do have is this. Do we see that this is in the same spot? So based on what we did over here, wouldn't that mean that they're equal? Okay. If you looked at it sideways, like this one and then this one, aren't they in the same spot? If you looked at it sideways? Like if you rotated it? Well, I'm trying to show you, but I don't think it's going to work. But anyway, if you did that with both of them, if you did both of these and looked at them from the side, isn't it blue, green, blue, green? Okay, so anyway, but you see that we already determined that these were the same amount because they were in the same spot as these. So that means that these are also equal to each other. So what would E and C be? Sorry. Jaren. What color would E and C be?
Blue.
Well, these are blue. You see the blue? This is on the other side. So it'd be on this side of the transversal. cause these are over here. Y'all see that? Okay, so this is why they are equal. Okay, let me draw the a little bit better. On this one, on this side.
Miss Bell,
Mhm.
why are the ones opposite to D and B green?
That's what I'm.
Okay.
Because they're the same. It's just flipped. They're still a cute.
They're all acute angles.
Okay, well, maybe I just see
They would be blue.
Yeah. Okay, so let me draw the thing, okay? So on this side, this is where B and D are, right? Okay, so we determined those were green, right? Okay, then on this side we have and I thought that we determined that these were green.
They are. Because, 90 degrees is a right angle, and anything like above 90 is obtuse,
Yes.
and those aren't right angles.
Yes, okay, what happened, guys, was, I was just showing you where the location was. These are acute, you are correct, but I slanted my transversal differently, didn't I? On this side, the transversal is this way, making these acute. And on this one, isn't it that way? So it's making those acute.
I see.
So they are still acute. I was just showing you the location that we had drawn before. We were saying that these were green and these were blue. I was just showing because of the location.
Okay.
But what I drew over here was like this. Do you see how my transversal changed? So now this side has the acute angles.
Okay.
Yes. Yeah. Oh. Huh?
I get what she's saying now. It was confusing me because I was like, I thought green were obtuse.
Yes, no, you were right on the acute thing. I didn't draw the whole thing. There you go.
What's throwing me off?
It threw me off because I was like, what?
But no, you should ask those questions because that is true. But what happened was is my transversal changed us. Okay, so we're gonna move on. Hopefully we can kind of see. But on this, you have this big triangle, right? ABC. And the little triangle is made from the big triangle, correct? They have to share angle A because it's the same angle, it's the same triangle. And what you see is this creates, by cutting it, this creates the same angle. So D is the same as B, and then this creates the same. So this is the same as C and E. So if they all have the same angles, but they are different, what? No, size. They have the same shape, right? If they have a different size but the same angles, they are similar.
Oh, so this was the whole step forward, step backward thing?
Because if they have the same angles, don't they have to be similar or congruent?
Yep. Yes.
Everyone.
Yes.
If they have the same angles, don't they have to be similar or congruent?
Yes, ma'am.
And they're not congruent, why, Kyle? Why are they not congruent?
Did they have the same angle? Because
Please don't do that.
why aren't they congruent? Because that one's green.
That's exactly why. If one is bigger than the other, they can't be congruent, but they can be similar. Okay? Yes, same angle, different size. Very good. Okay, so let's look at the stamp page. So do you see that on your book?
131.
I feel it.
Oh, but I knew you had it. Okay, so this is what you're going to see a lot of, is different sizes. I want you to do a quick draw of these stamps. All I want you to draw is this with the measurements, this with the measurements. You do not have to put all those little arrows. You just have to put A, B, C, D, E, F, H, G, and the measurements. So just do a quick sketch. Quick sketch.
Both of them?
Yes. Oh, you do it on there. You must do it on there. And look at me when you are done, or look up here. Again, that doesn't have to be perfect, just quick sketch.
Did you do that?
Okay, who can tell me what type of figures these are and why? Lay down, go ahead.
Two rectangles.
Okay. And what type are they? Are they similar, congruent, or neither? Why do you think they're similar?
Because one of them is bigger than the other.
Okay. And what else do you think is the same?
Same? Oh, the measurements?
Well, one has 2 and one has 6. But you tell me they're rectangles. So what do rectangles have that are the same?
Oh.
You got it.
Angles.
Do they have the same angles, guys?
Yes.
Yep. Yes. Okay, so everyone should be through drawing. Now, what we're gonna find is you're gonna be given similar figures, and you're gonna have to find missing links. Okay? You're gonna have to find missing sides. These are not hard, okay? And you're gonna see that. So, do you remember how we talked about the picture on Microsoft Word when you inserted a picture? You could not just simply stretch it because it would mess the picture up and become blurry, or that way, right? You want to pull it from the corners because the corners would take it out from all sides. Remember how we said that was the same with this? If we just simply add or subtract, we're only adding length or subtracting length. We need to pull from every side, so we're going to, what are we going to do instead of add or subtract? Always. So put a star somewhere in your notes. Always multiply or divide.
This goes in my notes.
You can keep it with that and put that in your notes. Always, 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 you will be multiplying or dividing.
Would you go for the multiple?
draw something common.
Two times three.
Would that work?
Yep.
Or 6 divided by 3 gives you 2. So remember how I said it's multiplication or division? You can pick which one you want. Now, here's the thing about the scale factor. Remember how we said what we do to one side, we do to all?
Yep.
Because you're pulling it. If you multiply or divide by 3, you have to do the same on every side. So, would 3 times 3 be 9?
Yes.
Or 9 divided by 3 be 3?
Yes.
Okay, and then we know the other side because they're rectangles. Okay, so this is called a scale factor. Do you remember us talking about that? With the tree house and things like that, how many times bigger is something than the other? This stamp is 3 times bigger than the smaller stamp. Or, the small stamp is,
3 times smaller.
yes, what's another way to say 3 times smaller?
Divide.
Getting there?
Tiny.
No, using 3.
Less than
No, using 3.
3.
3 less than.
Less than.
No, because 3 less than means minus 3.
3 divided by. 3 to 6.
Okay, 3 to 6,
Ratio.
but 3 to, it's not actually 3 to 6.
The quotient of 3.
1 to 2 means 1/2.
1/3.
So we would either say this is 3 times bigger, or, and put this on your paper, or 1/3 smaller. Does that make sense? You do the opposite. 3 and 1/3 are opposites of each other. This 3 is 3 over 1. The reciprocal is 1/3. So you will say either way. And if you look down at the bottom, do you see how they give you 3 as your scale factor? How they put 6 over 2, 9 over 3? Well, reverse that. 2 over 6 gives you,
3. 1/3.
and 3 over 9 gives you,
1/3.
so that's how you can say either one. 3 times as big or 1/3 as small. Okay? Alright, so let's turn to the next page. And we're going to look at the triangles at the bottom on the other side. Oh, well, look at the green triangles. We can do that one. Alright, these are still in the same spot, right? Okay, so what would be the scale factor for this one? Raise your hand if you figure it out. So we want to find xy. And we need to know the scale factor. We can,
Well, 3 and 6, you multiply by 2, and 6. And you can just multiply 5 by 2,
does that sound right? Is each side increasing by times 2? Guys, if you find one multiply or divide, it's true for all of them, right? So you don't have to question yourself. If you get 3 times, there's only one way to get 6 from 3 with multiplication. 3 times 2 is 6, so 5 times 2 is 10. Does that make sense?
Yeah, I do it, yeah.
This is the easiest way if you have these types of triangles. But look at the other side real quick, and we're gonna do this one tomorrow. But look at the other side, where they give you the other triangles. is there a scale factor? How do you go from 3 to 5?
Multiply by 1.5.
It's gonna be a decimal, isn't it? Okay, and you can try that 3 times 1.5. So Tyler, what are you getting? Okay, she said 1/2, you're telling me 1.7, so how did you get that? 5 divided by 3. You can divide.
I was close.
Yeah. Yeah, so it's not, so you would see that it didn't work, and so you would try another number, right?
Go up.
But the best way to do it is just divide, and that is your scale factor. And we're gonna finish with this one tomorrow, because there's actually something else you can do as well. You can use a
Formula?
proportion, thank you. A proportion. Brendan, why do you think we could use a proportion? Let's listen. Why do you think you could use a proportion? When did I say that you use proportions? When you have this and this. You cross multiply. What gives you a hint that you could use a proportion? We need to stop putting up things. Okay, come back. You quite young?
Right.
No. Proportions don't have fractions. It looks like fractions,
Oh, yeah.
but they're not fractions. It's ratio. See, it came back to you. What is a ratio, Jaren?
Like something to something.
That's it, something to something. You're comparing how many things?
Two things.
2. Are we comparing 2 things? One side to another, 2 triangles?
Yeah.
Okay, and we'll talk about that tomorrow, because you have 3 things and 1 missing side. Real quick, what's something you learned about similar? Maurice?
Did they have the same angles?
Yeah, the same angles. Very good, Zach.
They be the same shape but not the same size.
Same shape, different size. Courtney?
The sign is
The sign is a squiggly line. Heather?
The angles never change.
The angles never change. Quavion? Brendan? The tally marks. What do they mean? Guys, y'all put in here because y'all putting up. We would already be putting up right now if y'all would listen.
Earlier, when we saw the two triangles,
Mhm.
and the towers on each side,
They mean what though?
each sides are equal.
Each side are equal. Very good. All right. Do Quavion real quick.
Always multiply by that.
Always multiply and divide. That couldn't be a better ending note. All right. Please fill out your objective sheet. Throw away your paper or recycle. You probably recycle them. You don't need them anymore. Put up your rulers and retractors, calculators.
Recycle.